So to do a proportion, we're going to use the very same method we've already been using to solve fractions or to clear fractions. So I call the bowling ball method. And the trick is find the right size bowling ball, because too big, it's going to be a problem. Too small, it's not going to be the one you need. All right? So check it out. Number 2 on page 150, 7/8 equals m over 4. Again, there are different methods to this. One of them is cross multiplying, but I'm teaching the same thing. Whenever you see fractions, you clear the denominators. And whenever you see 2 or more, you have to find the lowest common denominator. And what would that be in this case? Any ideas? We've got 8 and 4. What number will be big enough so that they both divide into it? All right, big enough, but not too big to leave over leftovers. Yeah, Alex?
4.
The problem with 4 is a good one. It would cancel here. But if you put 4 here, it won't cancel with 8. It will be 1 over 2. 8 is the one. That's right. Good point. I'm glad you said that. 8 is the one. 8 is enough. Somebody remember that show? No. Too young. All right, so I'm going to put 8 in blue. Please do it too. Love to rhyme all the time. And there we go. Now we go ahead and cancel things. And ba-dum, that's equal to 1. We like that. 4 goes into 8 how many times?
2.
Dos. And what do we have left over here? Alex, do you want to keep it going? Just keep on going. What's 1 times 7?
7 is 7.
7 is equal to 2, what?
14.
No, because there's 2 left over here.
Right.
And 2 times what?
M.
There it is, and that's all it is, 2m. And now we're not done. We have to go ahead and divide out what? We have to divide out on both sides. Austin or Sivan? 2, that's right. Divide it up on both sides by 2. M equals, the answer is 7 over 2. When we divide by 2 on both sides, we end up with 7 over 2. Very straightforward, and we'll go on to number 16 now. 24 over x equals 4 over 3. What do we do on both sides? Again, we're looking to clear the denominators, and we have to find that magic number, or expression, I should say, to clear the way. And I call it the bowling ball, but that's just my little metaphor. Yes, Shannon?
Wait, so should I give you the number?
Yeah, give me what you think would clear both the x and the 3.
6.
6 would clear the 3, and it wouldn't clear the x, though. Why 6? Why did you pick 6?
Because they all go into 6.
What? No, you don't care about 24 and 4. You only care about the bottoms.
3.
3 would work for the 3, but it doesn't do anything for the x.
1.
1 doesn't do anything ever because it just always goes in.
Here.
Nothing goes into 1. X is good. X is good, but you've got 3 for that and x for that. Which one? Or both? Or what? How's it going to work?
3x.
Perfect. Nice job. 3x is it. Right here. Because 3x, this expression, will work for both. And it's also, furthermore, the lowest expression that will work for both. If you put 6x, it would be too big. Right? The ball's too heavy. Right? You're going to end up with too much on the top. So, x goes into 3x. How many times? X into 3x. Jonathan?
1.
Yeah, well that cancels out, and what's left over? 3. 3 times 24 is?
72.
Yes, sir. Good stuff. The brain is working today. Nice one. All right, now what about 3x? 3 into 3x, Amanda? What goes here into here? What is it?
It would be x left over.
Yes, x left over. That's good.
4x.
That's right. X left over
Such an
equals 4x. And now we're almost done. What do we do on both sides? Go ahead. Divide by what?
4.
Yeah, the standard stuff. X equals what? What? 18? There are easier methods for this, but the reason the book teaches it this way and the reason I'm teaching it this way is because I want you to see, first of all, I want you to practice the full method and be able to use it whenever you have to. Whenever it's a hard problem or simple problem, you want to be able to clear the denominators. You have to find the lowest common denominator. The lowest common denominator, right? A number and letter, or what we call an algebraic expression that is not too big, not too small, just right, so that these denominators divide into them evenly, and these therefore disappear and get knocked down, just like our. But, okay, having said that, yes, there's an easier method, and it's no problem. You can use it if you want, it's okay, but I want you to see the connection between the other way. The easier method is, Sophia, do you want to tell us what it is? That's right.
8m.
8m equals,
Equals 28.
that's right. And it's a lot easier. So divide by 8 on both sides, m equals 14 over 4, which is equal to 7 over 2. There it is. See how easy that
Wait,
is?
what did she do?
She just went 8 times m equals 4 times 7. And that's absolutely correct. You can do that method. It's no problem. The method that I showed you, which is the method, okay? So, right here, 24 over x equals 4 over 3. We can do the cross multiplication method because this is one fraction here and one there with an equal sign. If you had two fractions, you couldn't do it. If you didn't have an equal sign, you wouldn't be able to do it. But because this special case provides you the opportunity to what we call cross multiply, you can. Now, we're going to go right here. 24 times 3 equals x times 4. That's what we call cross multiplication. So Alex, what are we going to get when we go 4 times x?
4x.
Good stuff, man, good stuff. Okay, so our final answer is x equals 18. And we're getting the same answer that we got the other method, which is kind of, they're not hard, they're simple, and what you need to do is just basically recognize that these problems have proportions in them. In other words, they're just disguised ways of setting up a proportion. So like in number 27, can I get somebody to read it out? How about Marshall?
A watch loses 2 minutes every 15 hours. How much time will it lose in 2 hours?
Right, a watch loses 2 minutes every 15 hours. How much time will it lose in 2 hours? So you got to find the numbers in here. What are the numbers, Ingrid? Which one are the numbers that we're going to set up? How are we going to set up a proportion? A ratio. Just find the numbers. 2, good. 2 minutes, and what? Yep, 15. What else? There's one more.
2 hours.
Not, yeah, then 2 hours here, right? Okay, now notice that we have hours and hours. And we have minutes, right? Minutes and minutes. So we've got to set up a proportion so that things are proportionate. And we'll see how we do that in a second. A watch loses 2 minutes every 15 hours. How do we set that up? 2 minutes every 15 hours.
2 over 15.
15. That's one way to set up the ratio, okay? Now, equals, now this is, again, this is minutes, and this is hours.
This is turning into like chemistry.
So now how are we going to set up this proportion? Yes,
X
awesome.
over 2.
X minutes,
Over 2.
all right, over 2 hours. Now you notice what I did. Why did I bother putting minutes and hours here, Talia? Why did I bother to put those?
So you were very confused.
That's right. We want minutes over hours equals minutes over hours. You have to be very careful to set it up right. If you don't set it up right, then you can't get it right. So there we go. Now the cross multiplication method is just fine, but if you didn't use that, I would say multiply by what on both sides?
30.
30, right? Because that's the one that clears it out. I'm not going to do the cross multiplication method. I'm going to go ahead with the full method because it's just as easy once you get it, and you need to practice it because it's super important. That's like really, really important.
When I did the-
Gabby, what do we get? We go 15 into 30 how many times?
15 to 30.
Yeah.
I was gonna tell them.
Okay. Go ahead, tell me.
15.
2 times. 2 times 2 is, right? So we got 4 over here. And then 2 into 30 how many times?
15.
15. Right? And then 15 times x is? Good. We're almost done. What do we do to the 15 on both sides?
Divide.
Divide 50.
Divide by 15 on both sides other than blue.
Radar.
And our final answer is x equals 4 over 15. And I'm just going to put that in a box.
It's not a box.
There it is. Well, it's close enough. It's a tetrahedron or something.
Something like
All right?
that.
Like a something. It's a Jurassic Park thing. I don't know what.